Good evening, everyone. My name is RJ Sunderman, and sitting here with me is Sagar Ayare. We are product engineers on the real-time GeoEvent Server product team, and this session is an introduction to GeoEvent Server. So thank you for joining us as the last session for your day. Quick look at the agenda for this session. We're going to be defining the term real-time GIS. What does it mean when we say things like event record or real-time analytic? Sagar is going to be taking a look at working with real-time data through a demonstration, making features come alive. I'm going to be discussing an introduction with applying real-time analytics. There's a deeper dive into real-time analytics coming up on Thursday. Then Sagar will be discussing a little bit about stream services, integrating real-time data with web apps, and wrapping up. There should be about 10 minutes when we're done if you have questions. GeoEvent Server at 10.5 is not an extension of ArcGIS Server. It is something that extends or enhances the capabilities of your ArcGIS Enterprise. It is real-time for your data enterprise. It has 5 key capabilities. The first is making it easy to ingest data from real-time data feeds, such as JSON feeds or XML feeds. All you have to do is configure an out-of-the-box connector rather than write code to try and bring in these data feeds. Once you've brought in these event records into the GeoEvent server, we want to be able to perform continuous analytics on the data. We want to be able to filter and process the event records as they are received, and that's what we mean when we say real-time analytics. GeoEvent Server extends or enhances the ArcGIS data store as a component of your enterprise with a NoSQL database, an Elasticsearch spatial temporal big data store. That enables you to store larger volumes of data at higher velocity than you might otherwise be able to using a relational database such as Oracle or SQL Server. Once you have begun to accumulate large volumes of data, using another functional server, GeoAnalytics, you can do batch analytics on your data. GeoEvent also provides the ability to visualize high velocity and high volume data using on-the-fly aggregations. And finally, notify those who need to know about patterns of interest as they occur. I'd like to take a look at 3 of these that we're going to examine in this session and then invite you to visit us over at the Real-Time Island if you would like demonstrations of capabilities such as the on-the-fly aggregation or the spatial temporal big data store. So what is real-time GIS? I think we're all familiar with the concept of a feature record and the fact that you bring attributes that have location associated with them into a geodatabase in order to expose through a map or feature service. The challenge is that with the growing number of sensors out there in the world, what with sensor networks and social media feeds, vehicles that are reporting their GPS location, the data is almost out of date as soon as it is loaded into your enterprise. You need a way of connecting up to a real-time data feed to bring the data in as it is produced. A couple of examples of real-time data. I mentioned automated vehicle location, or vehicles that are supplying their GPS coordinates, police cars, ambulances, any vehicles that are in a commercial fleet. Probably here stateside, AVL is the largest single adopter in the GeoEvent space. But we can also track individuals that are walking around with phones or radios. So now we're dealing with personnel safety and making sure that we know where the people are and that they are where they're supposed to be. Sensor networks, measuring temperature, pressure, humidity. We could have a sensor network spread throughout this building with 500 different sensors that are giving us environmental controls and readings in real time so that we know if people are reporting that over in Smoke Tree it is getting warm, it's because the sensors in that area of the building are 10 degrees out of tolerance and there's a problem with the HVAC at that end of the conference center. You could also attach RFID tags to critical equipment if you wanted to track where certain life-saving equipment was as it moves around a hospital, for example. Lots of different examples of where we might be receiving real-time data. Another key capability that we're looking at is the ability to do some sort of analytics on that data, such as detecting spatial coincidence. In this slide, what I'm discussing is the concept that we've loaded a geofence, an area that fishing vessels are not supposed to enter, into the GeoEvent server. And then as we receive AIS reports or GPS reports from the different fishing vessels, we can detect spatial coincidence inside, outside, intersects with that geofence in order to display meaningful information such as alerts. Speaking of alerts, we have the ability with GeoEvent Server not only to add and update features in a geodatabase, but to push out SMS text or email alerts. Because we don't want to be slaves to a web map waiting for a green light to turn red or vice versa. We want to be alerted when something is happening that drives us to go look at the web map in order to do an analytic and determine an appropriate response. In this slide, what we're saying is that a bracelet that is providing a location, say like on a child, if that bracelet has left the school area during a normal school day, we want an SMS alert to go out to a parent so that they know their child has left school. So those are the 5 core capabilities of GeoEvent Server, bringing in real-time data in a configurable manner without having to write code. Like I say, we're not going to be looking specifically at the spatial temporal data store or geoanalytics. Some of those capabilities, if you're interested, please come visit us over at the island. With that, I'd like to hand the presentation over to Sagar, who's going to talk a little bit about making features come alive.
Thank you, RJ. GeoEvent Server ingests real-time streaming data from a wide variety of sources using the input connectors. There are a number of out-of-the-box connectors which are provided with GeoEvent. As you can see here on the left, the ability to pull an ArcGIS server for features, pull an external website for JSON, GeoJSON, or XML. You can also receive features, GeoJSON, JSON, or a REST endpoint, or maybe on a WebSocket. You can also receive RSS feeds, or receive text on a TCP or a UDP socket, or subscribe to an external WebSocket for JSON or GeoJSON. If you have your data in the form of a flat file, or maybe CSV, GeoJSON, or JSON format, you can also have GeoEvent look for a folder. So those were all out-of-the-box connectors. As you can see in the center column, we have a lot of community-based connectors which are available on the Esri gallery. There are enterprise messaging applications like ActiveMQ, RabbitMQ, Kafka. So we have connectors for that. CAP, which is a common alerting protocol which is used in emergency applications. An MEA 0183, which is a GPS standard, so if you have a device that is emitting an MEA 0183, you can have that data into GeoEvent. We also have connectors for social media, Instagram connector and Twitter connector, as well as connectors for Sierra Wireless and Trimble. We also work with Esri partners who have developed connectors to meet their specific requirements. We developed Amazon IoT and Azure IoT connectors. Let's say if you want to bring your SCADA data, you have the OSI soft connector. Or if you want to take a look at the 250,000 vessels across the world on an Esri map, you can use the Exact Earth AIS connector. You can also have data from your city using Waze into an Esri map using the Waze connector. The connectors in the center column have their associated GitHub projects, so you can fork them as well. In addition, there's also GeoEvent Java-based SDK, so you can create connector of your own if these connectors listed here do not meet your requirement. Similar to the input connectors, you also have output connectors. So GeoEvent Server disseminates real-time and analytic results using output connectors. There are a number of out-of-the-box output connectors with GES with GeoEvent Server, as you can see here on the left. You can add or update a feature or publish text to a UDP socket. You can push JSON, GeoJSON to an external website or a WebSocket. You can send text message, SMS, email, or instant message. You can also send features to a stream service. You can also write to a CSV file or GeoJSON or JSON file. Let's say if you have high volume, high velocity data and you're interested in working with the spatiotemporal big data store, you can use GeoEvent to add or update a feature. We also have connectors on the Esri gallery for Amazon IoT, Azure IoT, and enterprise messaging applications like ActiveMQ, RabbitMQ, Kafka. You can also write to your Hadoop or MongoDB. You also have a connector for Twitter. Similar to input connectors, these connectors also have their associated GitHub project, so you can fork those and create a connector or expand based on your requirement. If any of these connectors listed here do not meet your requirement, there's a Java-based SDK, so you can create your own connector as well. Now that you have seen about the input and the output connector, next we are going to take a look at how to apply real-time analytics to streaming data. For that, you need to create a GeoEvent service, which essentially defines the flow of your event data. Between your inputs and outputs, you have your filters and processors. Filters can be attribute filters or spatial filters. As you can see over here, the data is coming on a TCP port. Data in this case is a vehicle data. And you have 4 outputs. We also have 3 processors over here. We are trying to monitor the speed of the vehicle. Let's say, for example, if the vehicle is speeding, you can get an alert. We can also monitor the dangerous area, for example, which is essentially geofencing. Let's say if the vehicle that you are interested enters or exits a particular geofence, we can get an alert. We can also get an alert in the 3rd processor. Let's say, for example, if the vehicle is at a particular distance or at a particular time, you can get an alert for that. An alert can be in the form of an SMS or an email. So how do you work with real-time data in ArcGIS? Let's take a look at the high-level steps for making features come alive. The first step in this process is to connect the output to your feature service or maybe the stream service. Next, you'll import the GeoEvent definition. Now, what is the GeoEvent definition? It is essentially the schema of your underlying incoming data. A GeoEvent definition essentially lets the GeoEvent server know what the structure of the incoming data is. It includes their attributes and their data types. Next, you need to configure your input to connect to your real-time streaming data. Now that you have your input and your output, you need to connect your input to your output using a GeoEvent service. And finally, you're going to visualize your features on a client application, like maybe an operations dashboard or a web map. So let's move on to the first demo of the session, making features come alive. In this demo, we are going to take a look on how you can bring your Waze data on an Esri map through GeoEvent. To do that, I need to log into GeoEvent Manager. Now, GeoEvent Manager is very similar to ArcGIS Server Manager. You can create your inputs, your outputs, and GeoEvent services, as well as you can perform administrative tasks like importing and exporting GeoEvent configuration. You can also import and administer geofences. You can also import and export GeoEvent definitions as well. So the first step, as I mentioned in this process, is to create an output. So I'm going to send features to a stream service in this case. So I'm going to create a stream service output connector. So these are the properties of stream service output connector. I'm going to name this as a stream service out, and I'll connect to the default ArcGIS server, and I'm going to select the GeoEvent definition Waze alert. I will take a look at that definition in a minute. I'm going to publish a stream service, and a display field name will be UUID. That's the track ID in this case, and the geometry is point. So stream service is published, and I'll save the connector. Now let's take a look at the GeoEvent definition that I use in this case. I use the Waze alert GeoEvent definition. The GeoEvent definition essentially consists of the name, which is the attribute, and the type. What kind of, is it an integer, string, geometry, or timestamp? Cardinality, and if is it track ID or geometry? Let's take a look at the stream service that just got published. So I'll navigate to server REST. And this is a stream service which has essentially the same fields. That includes the location and UUID as well. Let's go back to GeoEvent Manager. Now the next step in this process is to create an input. I'm going to receive data from Waze. So we have a Waze connector for GeoEvent. So I'm interested only in the alerts, that is traffic incidents from Waze. And the default area of interest that comes out with the connector is around the city of Los Angeles. So that's the polygon. I'm going to change the frequency to 30 seconds. So every 30 seconds, GeoEvent is going to look for updates. And I'll save the connector. Now that you have your input and your output, you need to create a GeoEvent service that is essentially going to connect your input to your output. So Service Designer is a model builder type experience wherein you can drag and drop your inputs, your outputs, and your filters and processors as well. So I'll drag and drop my input and output that I just created, and I'll connect it. And I'll publish the GeoEvent service. Now let's go back to the monitor page. Now that you can see out here that we have input, we have output, as well as GeoEvent service. Let's take a look at the map. You can see that events are flowing, 2885 events in and 2885 events out. Let's go back and take a look at these events on a map. So this is around LA. So maybe let's take a look at a feature. It's about in the city of Carson, jam and jam moderate traffic, and the street as well. So you can essentially create some application with this data coming into GeoEvent. Now RJ will continue with filtering and processing part of GeoEvent. Over to you, RJ.
So what I'd like to do now is take a brief look at applying real-time analytics, since filtering and processing on the events as they arrive is one of the core capabilities that you want to use GeoEvent for. A filter is something that discards event records based on an expression. Only event records that satisfy the expression are allowed to pass through the filter. In this first example, you see that there is no filter, and as Sagar showed, all of the events are flowing from the input to the output. You can filter based on an attribute expression, such as is snowplow. You can filter based on a spatial, such as is in dangerous area. You can combine both the attribute and spatial expressions within a filter to look for snowplows that are in dangerous areas. So I'd like to take a look at that and what it looks like in a demonstration. In my GeoEvent server here, I have a simulator that I'm going to use to simulate some vehicle reports. I've created a couple of different services with inputs and outputs, and I've turned on the outputs that are going to send event records out to a geodatabase to add and update feature records. If we simulate a few of these records, as soon as the web map refreshes, I'm going to have to fix that demo. Would you please go ahead and call up the slide deck and continue with the next section? Actually, hold on one second. Sorry about that. I had a filter actually in place that was discarding all of the data. That's why nothing was showing up on the map. So here I have the ability to send data into GeoEvent extension. You can see that some of those vehicles began to move forward. If I turn on my legend here, you'll see that a larger diamond is used for the vehicle's latest position. That's an update of feature with some smaller dots showing a vehicle history report. So as I click the simulator to continue sending data, the web map will refresh and the trucks move forward on their routes. If I take a look at filtering now, I can come over into my GeoEvent service and rewire the event processing. So here's a filter that is looking for a vehicle type of snowplow. That's a literal string, one of the string attributes in the data that I'm receiving. All I do is include the filter in the event processing routes, click publish, and now when I come over to my map, you'll see that only that gold diamond, that snowplow, is moving forward. So the blue truck is not moving, and as I failed in the initial part of the demo, there were no dots displaying because I was filtering all of the data that was coming out. I can look at a different filter if I want, taking out the filter for just is snowplows. And the second filter is combining logical expressions for looking pickup trucks that are in a high-risk zone. The high-risk zone is that geofence that you saw over on the right-hand portion of the web map. If I publish the changes to that GeoEvent service and simulate some data, you'll notice a gap in the pickup truck because several events were discarded from that earlier filtering. But now the snowplow does not appear to be moving forward, and the pickup truck is, because it is both inside the high-risk area and it is a type pickup truck. We use processors when we want to calculate new values, enrich event records, project a geometry, anything that's going to change the event record that you're working on. A couple of common processors might be a field calculator. A simple field calculator can convert meters over to miles or concatenate two strings together. Field calculator accepts a configurable expression. You can actually invoke some of the Java string functions that provide some very powerful capabilities to do regular expression pattern matching and replacement when working with strings. A field mapper is responsible for changing the structure of an event definition. Often the JSON or XML data that you're going to be receiving could be hierarchical and complicated in nature. You need to simplify that structure before sending the data to a stream service or to a feature service to add and update feature records. A field enricher does an attribute join on an external table in order to enrich the event record that's being processed with information out of that table. If we're dealing with fixed sensors, for example, that are not moving around, they're probably not broadcasting a location. But in order to see them on a map, you need a location, so you're going to enrich from an external table to bring that location, that geometry information, into the event record so that you can display it on a web map. A geotagger works with geofences to identify spatial coincidence, such as inside or outside, and enriches the event with the name of the geofence that the event record shares a commonality with. An incident detector is one of the monitors that uses a filter expression when that filter expression is true, such as vehicle outside area or vehicle speed greater than 50, can open up a new incident record and begin tracking the duration of that incident. Finally, track gap detector is another monitor. If you have configured track gap detector to say, I expect vehicle reports every 2 minutes, and it has been 5 minutes since I've heard from a particular vehicle or from a particular staff member on their phone, then new records are generated by the track gap detector to alert you to the fact that data that was expected is missing. Taking a look at some of these processors in a demonstration, I'd like to look at incident detector and track gap detector. For this, I'm going to open up a new web map just so that I don't have the old data on the screen. And I'm going to come over to my GeoEvent Manager, and I'm going to turn off the inputs that I was using for the earlier demo and turn on this demo number 2. You'll see here toward the bottom of my screen that I have some notification outputs, email and SMS text. I'm not going to include those in this demonstration since it's going to be difficult for you to hear my phone when it chimes that I've received a text message, and we don't keep our email open during presentations. But if you'd like to see some of the notification possibilities, again, please stop by the island and I'll be happy to demonstrate this for you. With those services running, take a quick look at what the service looks like. We have a couple of incident detectors, the track gap detector, and multiple different outputs that are using add and update feature records to display the data on a web map. When I simulate a few data records, we should see alerts popping up over here in the dangerous area. I can zoom in and show that if I were to even start playing the simulation, those alert records start to move along with the truck as it moves through the area. I can click on one of the alerts, that's the vehicle's latest report, but here is the incident that the vehicle is passing through a steep zone area, and it's been ongoing for the last 17 seconds in demo time. If I send a few more data records and allow that alert to move forward, when I click to identify, you'll see that it is tracking that has been ongoing for the last 38 seconds. Going to zoom out a little bit because I'd like to take a look at another set of data that is included here. You'll see that this vehicle has been detected as speeding. That's a different alert and a different incident detector in my real-time analytic. It is a pickup truck, that's its latest location. Its alert is speeding and has been going on for the last 39 seconds. If I just pause for a moment and don't simulate any data, the track gap detector is going to start providing me some alerts because there's nothing coming in from the event simulator, therefore expected record data is not being received, and that's what the track gap detector is looking for. So there are my alerts. If I click on one of those, there's the latest truck report, but here there's a track gap that started tonight at 5:59 p.m. because a track was detected as true on either truck number 4 or truck number 5. So you can see the incident detector and the track gap detector use filter expressions just like filters, but they are processors and they are generating new data based on the detection that they were configured to look for. Spatial operators used by both filters and processors detect things such as a point inside a geofence, but they can also keep track of state. We don't necessarily want to know every time that a vehicle's report is inside the area that it's been assigned to. We want to know when it has entered. And in order to do that, we need to track state so that we know the last time we observed the vehicle, it was outside. All of the Java geometry operations that are supported through that Java Geometry API are supported within GeoEvent Server. Inside, enter, intersects, touches, we can detect all of these relationships between an event's geometry and a geofence. Events might not be reporting points, they might be reporting polylines. That's where we can start to look at whether a polyline intersects or crosses a geofence. Geofences themselves, while often areas, don't have to be. You might import geofences from a feature service, for example, that are points representing critical facilities. To take a look at that as an animation, here we have a storm that is approaching the east coast of the United States. And we've buffered that storm so that we have a little bit of early warning. We've determined that that buffer intersects one of the point geofences, and so we're going to generate an alert and send an email message. Inside that email message, we were able to encode a URL that allows the user to click, bring up a web map, and quickly inspect to see what the storm is doing and which of the critical facilities are about to be impacted. Quickly, I'd like to take a look at any versus all and how you select geofences in your filter expressions. So you'll see a pair of regular expressions there, .*/.*. That is selecting a set of geofences to consider for this analytic and has nothing to do with the any versus the all keywords. The .* on the first says any category, the second says geofences of any name. The first filter expression, geometry intersects all, says I want the event's geometry to intersect all of the geofences at the same time. Obviously, they would have to overlap in order for that to be true at any point. Geometry disjoint any, on the other hand, is often true because if you consider geofences, say, as county boundaries or US states, just because a vehicle is inside Arizona doesn't mean that it is not disjoint from California, Nevada, New Mexico, and every other state in the Union. What does this look like in terms of a graphic? Intersects any geofence. Here we have a track line with several track points from a vehicle that is reporting its position. The vehicle is found to intersect any geofence because at one time it intersects A and then later B and later C. But as I was saying, if you want to intersect all geofences, the geofences would have to overlap because there's only one track point on this illustration that intersects all 3 geofences simultaneously. As an animation, we might have a construction zone that we have fenced off, and there's different zones within that construction site that we want to start generating alerts when a vehicle leaves its assigned zone. So you can see we have some blue alerts popping up here on the screen as the different tractors are leaving the zone that they were intended to operate in. This tractor off to the right has left the construction site entirely and is disjoint from all the geofences. He should not be driving up this road. So that's a different class of alert that we want to highlight. With that, I'd like to hand the presentation over to Sagar to discuss stream services and integrating with your web maps.
Thank you, RJ. So stream services are a way to visualize your real-time data on a map, which is an alternative to feature service. Both are useful, but they have some key differences. Well, feature services are designed to visualize data that's in a database. Now, database can be a SQL or a NoSQL database. So every time, essentially, when you're trying to look to a feature, it's going to be a poll from the database. On the other hand, if you have stream services, they take out the middleman just to speak. Maybe your application subscribes to the service and the data is pushed across to the client. So your data is essentially not archived and it is directly pulled by the client. So which means faster visualization. Long story short, if you want to archive your data for analysis, you may use a feature service. But if you want to take a look at your data in a much faster way, maybe stream service is the answer. So how do stream services fit inside the ArcGIS platform? Stream services are something which is on the server side. The client applications display stream services using JavaScript API object which is called a stream layer. Now stream layer is something which is on the client side. With that, we wrap up with the session. ArcGIS Enterprise is a fully featured mapping and analytics platform. GeoEvent Server brings real-time capabilities to the ArcGIS platform, and the new licensing roles for the ArcGIS Server, which is a component of the ArcGIS Enterprise, allows it to be licensed in different ways. So you can use your GeoEvent Server as your real-time server. Now GeoEvent Server ingests real-time data using the input connectors. It processes and filters them and then sends it to output connectors. It enables continuous analytics to be executed on event data as it arrives. You can also add and update features to your spatiotemporal big data store. It also works with GeoAnalytics Server to make batch analytics on high volumes of data. It also provides solutions for high volume data visualization with on-the-fly aggregations using the spatiotemporal big data store. And of course, it alerts key stakeholders using notifications. We also have a lot of useful resources available. For those folks who are new, I would say the introduction tutorial, which is a thorough step-by-step guide. The stream service tutorial as well. It also has a video tutorial for stream services. If you are interested in high volume, high velocity data, then the spatiotemporal big data store tutorial I think should be very useful. The notification tutorial gives you an idea of alerting. We also have blogs and discussions wherein the community discusses about how they are trying to solve the challenges using GeoEvent Server. These tutorials are free to download and they come with simulated data, so you don't need to have production data. You can use the simulated data for testing your own application, creating and testing your applications. There are video recordings of these technical workshops available. So GeoEvent Server, in the past conferences, you can take a look at that video with the link provided here. There are a lot of sessions related to real-time and big data. They're going around in this conference. There was a session this morning on Internet of Things, which will be repeated again on Friday. There are two sessions for creating connectors and processors using the SDK. I think they should be pretty useful for the dev community out here. Adam Molenkoff, the product owner for real-time and big data, is going to present a session for real-time and big data GIS at a massive scale. He'll also present a session for best practices, so you'll get to know the tips and tricks of configuring GeoEvent Server. There's also a user presentation on Thursday for building Android-based applications using GeoEvent Server. And on Friday, you have making 3D scenes come alive, which is a really nice session. We highly appreciate your feedback, and I must say you can download the application and the Esri app, Esri Events app, and search for this session and provide your valuable feedback. With that, we open for a round of questions.